Okay, this is the introduction for lab number 17. This is the lab that's measuring pressure. And we know that the definition of pressure is going to be a force divided by an area, which is going to have a unit of newtons per square meter, also known as a Pascal. Now for this particular lab, if you were in my face-to-face class, I would give you a block of wood and you would measure the length, the width, and the height. So here I've kind of done that for you right here. Now we can calculate the volume. Remember that the volume is going to be equal to the length times the width times the height. So pretty straightforward. We also would measure the mass of the block. Here I've done that for you. And you're going to calculate the weight, where the weight is just going to be equal to mass times gravity. Can't forget that in all of Physics 101 that weight is mass multiplied by gravity. Then what we're going to do is we're going to draw a picture of this thing, and we're going to imagine putting it with the largest side down. So picture me having a block, and I'm going to draw it with the largest side down. These were actually a 2x4. Now we're going to calculate the area of the side that is being presented. So that's going to be, well, that area right there, only on the bottom of the block, and that's going to be the length multiplied by the width. And we can calculate the pressure exerted by the block. Remember that pressure is going to be equal to force divided by area. The force is going to be the weight, and here I have the area, so we're going to calculate the pressure. Then what I have you do is just kind of theoretically, take your block, and what would happen to the total force if you took a second block and you put it just like that right there next to the block? How would that affect the force on the table? How would that affect the pressure on the table? Then I said, well, what if I were to stack the blocks on top of each other? So what if I were to, kind of do one of those numbers? How would that affect the pressure on the table? And what would the pressure be kind of halfway down, so kind of right in the middle? Then what I have you do is I have you say, well, let me go ahead and suppose I were to turn that block around so the smallest side is now on the table. So now I'm going to draw my small side kind of on the table, just like that. And what I would kind of do is I would expect the pressure to go up. That's just like putting on a pair of high heels or something like that. So I'm going to calculate the pressure with that side presented. So now I'm going to use this area right there. So then what I have you do is I have you say, well, let's take this block and let's pretend like it's water. And it's going to have the same dimensions as the other block. Now here we know the density of water, and we know what would the mass of this thing be? Well, if we knew that density is equal to mass divided by volume, I know the volume of the block, so I could actually calculate the mass of that block. I would expect the weight to be larger because that block was originally wood, and we can also calculate the pressure at the bottom of this block. And what we can then do is we could say, well, just like the stacked block, would the pressure be halfway down? Then what I want you to do is I want you to write the pressure in the language of the depth, gravity, and density. So it's probably going to look a whole awful lot like this guy. Pressure is equal to density times gravity times depth or height. And then we're going to go to this simulation and we're going to test this. We're going to see that the deeper you go, the more pressure you're going to experience. And also, if you could increase the pressure, or increase the density, you can increase the pressure as well. So then what I have you do is I have you pop open this simulation and use the faucet to fill the hole completely with water. And we can measure the pressure in several different places. First, we measure the pressure at the surface of the water and think about what that is. We can turn the atmosphere off and then read the pressure, and that might help you answer the question above. And then what I'm going to have you do is I'm just going to have you measure the pressure at depth of 1 meter, 2 meters, and 3 meters. This entire time, please do keep the atmosphere off because I don't want to I don't want that be affecting it. So we can measure the pressure, and then we could also calculate the density of the fluid. Essentially what we would do is we would just say pressure is equal to density times gravity times depth. So what I would do is I would say that the density of the fluid is going to be equal to the pressure divided by gravity and the depth right over here. Then we're going to go to a different simulation and we're going to actually measure the same depths. One thing I forgot to mention, please do convert kilopascals into pascals when you're doing this. The simulation is going to read in kilopascals. Please do work in pascals. And then we're going to come over to this simulation. We're going to do the same thing, and you may be asking yourself, why should it be different? It probably should not be different. Then we can go ahead and change the fluid, and we change it to honey. We would expect the pressure to get larger because now we have something that is more dense than water, and I just have you repeat the calculation. So let's go ahead and take a quick look at the pressure lab. So very first thing, go ahead, fill that thing all the way up with water, and what we can do is we can add a ruler and a grid, and that's going to help me go ahead and measure my depths. So actually I'm going to go ahead and put that guy right there, and again I can measure the pressure here. I can turn the atmosphere off, and I can measure my pressure at all these places. I can come over here to my weird funny shaped ones. You have to fill this thing up again, and you can go ahead and measure all of your pressures, and you can change around the fluid density right over here.